Hello everyone, here we are going to present our project to you. First of all, we introduce you to our team consultant, Professor Dr. Haydar Livateri. Then our members are Abdurrahman, Abdullah and Anas. So saying Bismillah, let's dive into the real work. There is a critical problem in the field of chemical spraying industries. So let's see what's that problem. Working in such hazardous fields requires the workers to obey strict health and safety regulations, and unfortunately, in reality, the workers don't obey them usually. And we also have the fluctuating level of product quality when it comes to manual spraying processes like painting or other chemicals spraying. And not to forget that workers usually bend, couch, and stay in other positions that often strain the body while working with manual spraying guns. So, as it can be deduced easily, these problems cost the related companies a lot of financial expenses and harm the health of their workers. After looking for the available solutions in the market, we did a brainstorm session and came up with the table that compares the solutions with respect to the most important criteria in the field. We can easily notice that the Cartesian robot has the best total score out of other solutions, in which it's a pioneer in controllability, maintenance, material usage efficiency, cost, and safety. I think that you have already expected our selected solution regarding the previously mentioned comparison table. Yeah, it's the Cartesian autonomous chemical spraying robot. This robot can be implemented easily for various applications, and it can work in 5 degrees of freedom workspace by taking a 3D model of an industrial part. Then it starts spraying a chemical solution over the part autonomously with respect to the extracted dimensions and parameters via the specifically written algorithm, of course. The selected solution has its needs and requirements, so here we can see each need with its corresponding requirement. For example, in order to obtain a healthy environment, we have to have an autonomously operated robot. And to identify the shape of the object for the robot to spray, we will use an algorithm to extract the STL file data of the object and generate movement instructions accordingly. And to conserve the sprayed material, we need to focus on transfer efficiency term. This term refers to how much paint covered the part compared to how much paint got wasted. So this will lead us to choose the right paint sprayer. In order to obtain homogeneously sprayed layers, we have to design a precise control method for the industrial robot to be more consistent than manual operators, or let me say than manual operations, and in which the robots become more unlikely to make mistakes. Here we present to you the sequence of how our robot works. As you can see at the beginning of the flow chart, the part gets positioned at the exact spot, then we insert the 3D model of the part to our system. And then the written algorithm extracts and analyzes the surface's coordinates. Then our code generates the needed movement instructions, and these instructions go to the control algorithm, which in turn sends control signals to both the motors and the spring nozzle. Then the spraying process starts while the axial and rotational movements are getting executed simultaneously. Now, here are the listed motivations of our project for you to see. So, our robot helps reduce the contact between the workers and such previously mentioned hazardous environments. It also improves the general quality of the products, and it increases the quantity and speed of the work. It will help us to get more practical experiences in terms of engineering projects. And finally, as we can see, the market size of painting robots has increased up to 11% in the last 5 to 6 years. Now let's come to the way we will measure our success in the project, and to tell you about the limitations that we may face. Our criteria is planning and studying every step of the project in details, planning weekly meetings between team members, completely finishing the prototype of the project around July 2023, and not exceeding the specified budget for the project. And here are some of the problems that may slow down our progress. The lack of experience in our team about some topics that we will still have to learn throughout the design process of the project, and of course not to forget about time difficulties and study workload due to other classes. So the time duration for such preparations will be a little bit short. Now here we aim to be more specific and explicit, so we are presenting to you the general technical requirements of our project. First of all, we have metallic sigma structural profiles for the mechanical structure, track rail mechanisms for the axes to slide, stepper motors that will generate the movements, motor drivers for controlling the steppers, border conductors as encoders, power supply to activate the system, Raspberry Pi as the main brain of the system, a graphical user interface, and a communication system to establish needed interactions, spray nozzle for the spraying process, chemical spraying tank, and an air pump. Followingly, in order to sum up the previously mentioned spread information, this slide shows the quantitative and qualitative targets of our project explicitly. So the quantitative targets are reducing the number of the workers to at most 2 workers per workshop to monitor and maintain the robot, spraying chemical solutions 8 hours a day without a break, and producing the exact same pattern every time, saving 20 to 30% of paint or other coatings. And our qualitative targets are increasing the quality and accuracy of spraying processes, creating a homogeneous sprayed chemical solution layer with minimal errors, and making the robot as easy as possible to be constructed in any workshop field. In the implementation sequence, firstly, we will start with building the mechanical structure of the project using SolidWorks and Siemens NX. And for the electrical circuits design, we will be using Proteus and Altium Designer. And finally, we will be implementing the simulation and the algorithm using MATLAB and Python. Now, it's very easy to confuse what's included in the tasks of a project and what's not. So to be very clear, here are the in-scope tasks and the out-of-scope tasks of our project. The in-scope tasks are extracting dimensions from the 3D model, generating movement instructions, and spraying the chemical solution on the outer surfaces of the part. And some of the out-of-scope tasks are spraying multiple parts at the same time, spraying the internal invisible surfaces of the part, and spraying large-sized parts. Now, for us to be disciplined in achieving the needed tasks, we constructed this milestone schedule that has the time distribution of the main topics that will be carried out. It's worthy of mentioning that this schedule may be adjusted throughout the project according to any new emerging situations. And to be more consistent and precise, we distributed the whiteboard tasks on our team members, but this doesn't mean that we are working separately. We will be cooperating together to achieve every single task. To wrap it all up, here are the final expected deliverables of our project in this semester. A sufficient algorithm that reads inserted 3D models and processes them, a decent control theory to control the Cartesian robot, a simulation of the behavior of the robot, a complete 3D model that shows the 3D structure of the robot, and a final technical report for all of the work. Our project stakeholders are, in the first place, we have field workers. I mean chemicals field workers. And sequentially, all of the chemicals related companies. Then we have our consultant, mechatronics department, and in the end, we have health and safety organizations. So that was all what we have, and of course, very thank you for listening.